Okay, welcome to Module 7. This is the final module in terms of the analysis of data. So what we're going to do is perform a statistical test in the form of a t-test. And you can see we've briefly mentioned this prior when we talked about these error bars, where it says that you must actually perform a statistical test to draw a conclusion. So what my suggestion is wherever you create your graph with the error bars, whether it's a line or a bar graph, underneath you provide a summary of your p-values, and then you can perform the analysis interpretation based on both. So to complete the t-test, there is a couple of steps along the way where you have to refer to the OneNote. So here, this is going to tell us what option to choose, whether it's a paired or unpaired test. Further down, it tells us which p-value to use. And then down here is our interpretation table. So if we start from the start in terms of our data, I'll bring up the one I've been using. We can see, as per the other examples, we actually have to reorganize our data so that we can perform the test. I'm going to slightly reorganize my data a different way than I have previously. I'm actually going to stick my independent variable values across the top this time. So I've got 0, 10, 30, 50, and 70. So those are my sucrose concentrations, and I'll just put them in a different color just to make them stand out. Now, what are my trials for that 0%? It's these ones here. So again, I'm using my raw data. Remember that we have to paste values. Now, this table does not have to go into your report, but you do have to summarize the p-values that you generate from this statistical test. There is my raw data, slightly organized a different way. And what we now can do is perform our p-value test. And what we actually do is we can only compare between two groups of data. So this is where you've got less data, it's probably an advantage to you. So what we need to do is open the data analysis toolpack. So click on data and data analysis. And if we go to the bottom, you can see the t-test is actually 3 options. And we have to use the OneNote to decide which one you choose. So you need to read through these and see which ones apply to the experiment you conducted. I know with this potato pack, it was completed a little bit like this, where everything was tested independently. I know that the variables were all controlled, and we can see that my sample sizes are all the same as well. So I'm going to perform, in my case, an unpaired test with unequal variances. So that's the one I choose. Once you've chose your relevant option, you need to input your variable ranges. So I'm going to compare first up the 0% sucrose concentration and the 10% sucrose concentration. Now notice, because I highlighted those titles, the 0% and the 10%, I need to click on labels here, because that lets them know that that wasn't actually a trial. This alpha number stays the same. It should always be 0.05, and this should be left blank. Then I'm going to select an output range, because I want to put what this data analysis produces on this same Excel spreadsheet. So you can click wherever you want it to present the data. I'm just going to click down here. So I've done that, and now I can hit OK. So you can see the 0 and the 10, that's representing the 0% concentration and the 10% concentration. You can see it's produced the means. They're those two means here, so it's got that for me. And you can see here we've got 2 p-values. We've got a 1-tail and a 2-tail p-value. So again, which one you use, you need to go read these to make your selection. For this case, I know the research question was they just wanted to know if there was a difference between the effect of sucrose concentration if there was a difference between the change in mass for each of those. So in my case, I'm going to choose the p-value, the two-tail option. So I'm just going to highlight it to make it clear that this is the p-value I'm looking at. And my number is 0.03. So you go back to this table now. Is 0.03 less than 0.05? Yes. So my statistical interpretation is there is a significant difference between the groups. That's great. And so we want to use that word significant. And then we can make a scientific interpretation which relates it a little bit more to the data you've collected. So here I'm just going to make a note. There is a significant difference. Significant. So then what you actually need to do is go and perform these tests to compare each of your variables. So I can go back up to data analysis. I know that I'm using unequal variances. I need to choose my data range now, and this time I might want to compare the 0% sucrose concentration to the 30% sucrose concentration. Labels are selected. That hasn't changed, that hasn't changed. Output, I'm going to choose my new output range, which I want it underneath. Hit OK. This time you can see I'm comparing the 0% sucrose concentration and the 30. Here is the p-value, because I've worked out I need to look at the two-tail. Again, 0.01 is less than 0.05, so there is a significant difference between these groups. And I'm just writing this to make that a little bit clear for myself when I'm ready for my interpretation in my report. So you would continue to perform those tests to compare your independent variables and the effect on the independent. Just as an example of something you could write to compare these two, referencing the p-value. Just give me a moment while I pull up my notes. Now remember, we're testing for a difference between these two. So is there a difference? Yes, we said it's significant. So we could say the change in mass now my unit is percentage because I did that analysis. And that's what my raw data are actually using. And then we need to include that plus minus symbol. There it is. And we're using standard error. We discussed that when we did our error bars. Obtained, so the change in mass obtained by the potato was, I'm going to include my mean values, which here was 2.69%, and then we're going to say plus minus my standard error, so I might need to go up a little bit. So my standard error is 1.38. And now I'm going to look at my 10% change in mass, which was negative 7.17%, plus minus my standard error, which was 2.14. This was the 0% sucrose and 10% sucrose concentration, respectively. So first I've made a statement. The change in mass obtained by the potato was this and this for these sucrose concentrations. Now what I want to do is refer to my p-value. So then I could say the mass, the change in mass obtained in the 0% sucrose concentration was significantly so you can see here, significantly different. For my data, it's not particularly greater or lesser. It depends on your experiment. So go determine if that greater or lesser or fewer word applies to you. Was significantly different than in the 10% sucrose concentration. And then in brackets, I can say the p-value was approximately, now this is much easier in Word where you would actually be typing this. Approximately was, if I scroll down, 0.03. And what you would do is round to, I'd round my, no, sorry, ignore that. There we go. So that's a statement I could make based on this data. Again, what I suggest is you create your graph, have a summary of your p-values, however you organize that, and then underneath that you complete the interpretation analysis based on both of those. Thank you.